Okay, now we are discussing symbol pendulum. Already we know very well about symbol pendulum. In lower class also we are doing a lot of experiment related to symbol pendulum. But there we don't know about the formulas and the derivation method. Now we'll discuss the derivation format also. A symbol pendulum is a heavily point mass suspended by a weightless, inextensible, and perfectly flexible string from a rigid support about which it can be vibrate freely. Everyone kindly draw the diagram. This is a point mass. This is total length L. Okay, listen now. The small point mass that is moving in this direction. For this one, Y total length up to in this point, that is L. This is A. From the center O, the force, that is the weight. Okay, it is a downward direction. Mg. I will take the component for in this side. That is a mg sin theta. This is mg cos theta. Making angle theta. This is theta. Listen, the theta is equal to y by L. So y means the main position to in this point O to A. That is the y. Again total length L. Theta equal theta is depends upon y by L. Theta is maximum means when it is maximum, the y is maximum in the central point too. The restoring force acting on the pop Pop means that is the point mass. F is equal to minus mg sin theta. This is the restoring force acting on the point mass. The negative sign indicates that the direction is opposite for the angular displacement. For the acceleration, A is equal to F by m, and the value of F minus mg sin theta divided by m. Then I will get acceleration A is equal to minus g sin theta. Now, the theta it is no sin theta, it is similarly equal to theta because it is very small angle only. So that you will get A is equal to minus g theta. And what is the value of theta? Theta is equal to y by l. Then A is equal to minus g y by l. Up to that you can note it. The weight it is no. Sorry, in this point. Where is that? Yes. The weight of mg, it is acting vertically downward direction. Mg acting vertically downward direction. The tension T in the string acting along the length toward the point of suspension. The tension in the string acting along the length. The weight mg of the pop acting vertically downward direction.
Sir,
Yes, ma'am.
for that theta equal to G by L, sir. Uh,
Theta equal to that is y, ma'am.
that is
Y by n. N theta. This is y. Finding the displacement, angular displacement. Theta equal to y by n. For the acceleration, A it is no, it is equal to minus g y by l. So based on that, you should understand the acceleration of the pop. It is a proportional to the displacement. Y is the displacement. It is proportional to the displacement. Our time period formula T equal 2 pi root of displacement by acceleration. Displacement by acceleration. So displacement y, acceleration a, 2 pi root of y by a. And in this equation, y by a equal L by g. So instead of y by a, I am applying for the value. You will get t is equal to 2 pi root of L by g. So this is the time period of simple pendulum formula. It is depends upon length and g. It is independent of mass of the pop, the amplitude of vibration, and theta. Now everyone today test completed. 65 students are there. Everyone completed or not? Okay, next one. That is a seconds pendulum. It is a special case. Same formula only. I just rewrite L equal T square G divided by 4 pi square. The value of T, it is 2 seconds, and the value of G, 980 centimeter seconds minus 2, and the value of pi, 3.142. Just to apply the values, you will get the L equal 99.3 centimeter. For the practical, you are taking the L equal to 99.3 means. So definitely it will come one acceleration for 2 seconds. It is related to simple pendulum. For the length of the simple pendulum is comparable to the earth radius. I will compare to the earth radius. The simple pendulum formula, this is extra mark, please note. Actual formula T is equal to 2 pi root of L by G. The length it is there, no? That is the radius of Earth. Now the formula will change. P is equal to 2 pi r root of capital R divided by G into 1 plus R by L. Maybe they are asking problem means you can utilize in this formula. The length of the simple pendulum is comparable to the radius of Earth, and the length is equivalent to radius R. This is the first one. Second one, that L is equivalent to R. Then you will get T is equal to 2 pi root of R divided by 2G. Then you will get the time period T value 59.84 minutes for the acceleration. Third condition, the length it is there, no, it is infinity. Then you will get T is equal to 2 pi root of capital R by G. So the value is 84.63 minutes. It is one more question mark. So related to simple pendulum, we'll discuss one small problem. Kindly note it. Note it. The acceleration due to gravity on the surface of Earth, the Mars, is the acceleration due to gravity on the surface of the Mars is 3.7 meter per second square. What is the time period of simple pendulum on the Mars? What is the time period of a simple pendulum on the Mars? If it is time period on the Earth is, if it is time period on the Earth is 2 seconds. Take G on Earth, acceleration due to gravity, 9.8 meter per second square. Again, I will repeat. The acceleration due to gravity on the surface of the Earth sorry, surface of the Mars is 3.7 meter per second square. What is the time period of a simple pendulum on the Mars? If it is time period on the Earth is 2 seconds, take G on the Earth 9.8 meter per second square. So this is the question. You want to calculate time period on Mars. First everyone write the time period formula. T is equal to 2 pi root of L by G. Okay, first I am calculating for the Earth. P value 2 pi root of L divided by G value 9.8. This is equation number 1. Now for the Mars, Tm, it is equal to 2 pi root of L divided by Gm. 2 pi root of L divided by 3.7, it is Tm. Equation number 2. Divide equation number 2 by 1. Equation number 2 divided by 1. Tm divided by 2. 2 pi cancelled. At a root L also cancelled. So what is the remainder terms? Only the gravity. Root of 9.8 divided by 3.7. Do the simplification, you will get the value of Tm. Do it fast. Tell me the answer through the chat box. For in this question, G only difference. In case some other question, the capital L it is there, no? L is different means we can compare like this. Yes, the Tm value 3.25 seconds. Please note it. Don't scribble anything, ma. Subhas. Okay. The displacement function xt x of t equal to b sine omega t plus alpha. The value of omega 2 pi by t. The displacement function x of t equal to b sine omega t plus alpha. If the initial position at, write the question, if the initial position at t equal to 0, initial position t equal to 0 of the particle is 1 centimeter, of the particle is 1 centimeter, I'll consider to x, that is 1 centimeter, and its initial velocity and its initial velocity v, initial velocity pi centimeter second inverse of the particle is 1 centimeter and the initial velocity is pi centimeter second inverse. What are its amplitude and initial base angle? You want to find the amplitude and initial base. Amplitude and initial base. The angular frequency of the particle is, the angular frequency of the particle is pi second inverse. So this is a question. We want to calculate amplitude. Next one, initial base. Okay. Centimeter you can take as it is, centimeter itself. No need to change anything. I'm just applying the value of t equal to 0, x is equal to 1 centimeter in equation number 1. Then I will get the value of x, it is 1, b sine omega t, t value 0. So omega into 0, that is a 0 only, plus omega 0 plus alpha. So you will get b sine alpha equal to 1. For the velocity, this is displacement. The displacement function only x of t. For the velocity, v is equal to dx divided by dt. Dx divided by dt. Do the differentiation, you will get velocity v is equal to b omega cos omega t plus alpha. This is velocity. Okay, now we can apply the value of t equal to 0 and v equal to pi. Then you will get, this is continuum, d cos alpha equal to 1. We can square both equation, b square cos square alpha and b square sin square alpha, add and square.